Okay, this is an example of a forces question from one of the practice tests. So we have two forces acting on a body at an angle of 55. I'm going to draw the two forces here. Here's the larger force, 85. Here's the smaller force, 25. And the angle in between them is 55 degrees. Remember, we can't use that angle. What we need to do here is create a parallelogram of forces so that this over here is also 25, this over here is also 85. They are looking for the resultant, which is the diagonal of the parallelogram. And this is the reason we can't use the 55-degree angle, because we have to focus on a triangle. I'm going to focus on the bottom one here. But that 55-degree angle is not part of that triangle, or of the top one either. It's just kind of like in between triangles. However, this angle over here is supplementary to the 55. So 180 minus 55 is 125. We are looking for the resultant in part A, so that's the diagonal. And we can use a law of cosines for this. So it would be, since the side we are looking for is across from the angle we have, that's a good setup. It's going to be x squared equals 25 squared plus 85 squared minus 2 times 25 times 85 cosine of 125. Remember, the law of cosines is given to you in the reference sheet. If you put this entire expression in the calculator, it comes out to 10,287.69985. That's x squared equals, and if you square root that to get x, you get that the resultant to the nearest hundredth is going to be 101.43. Be very careful with the rounding. Part B of the question says to find the angle between the resultant and the larger force, so that's going to be that angle right there. Let's call that angle y. And now that we have the 101.43, we are able to use the law of sines to get angle y. Sine of y over 25 equals sine of 125 over 101.43. If we cross multiply here, 101.43 equal times sine of y equals, 25 times sine of 125 is 20.479 approximately. Divide by 101.43. Sine of y equals 0.2019. Do sine inverse of that, and y is approximately, to the nearest degree, 11.6 degrees. Wait, to the nearest degree is going to be 12 degrees. 12 degrees for the angle, 101.43, and that's a typical forces question.